Okay, so sorry. This scale freaked me out because this thing is like way not to scale. Like 150 degrees. This is like not even 80 degrees. Okay, so which 150 is supposed to be obtuse, and this thing is like way cute. So, anyways, let's draw like a better, like more to scale version. So, like, let's say this is point A and B, right? And we're trying to find what this is, and this is 150 degrees, and this is 455 meters, and this is 620 meters. Okay, so this is kind of a difficult problem. So I'll walk you through it. So if you draw a right triangle outside, right, then this is 30 degrees. This is a right angle. And we can find like these two lengths using trig. So, for example, right here. So, for example, like y, right, you can do opposite over hypotenuse. So, sine of 30 degrees is going to equal to 620 over y. Right, and sine of 30 degrees, you can do in your calculator, but it's 0.5. So then 0.5y equals 620. Oh, I wrote this wrong. I'm like, sorry, opposite over hypotenuse. I'm like, I apologize. Okay, so it's 0.5 of 620 equals y. So y equals 310. So this equals 310. Okay, and then we could do the same thing for z. So cosine of 30 equals adjacent over hypotenuse. And then that one, you do need calculator. So make sure your calculator is in degrees, which mine is not. So I'll change it to degrees. Okay, so cosine of 30 is 0.866 equals z over 620. So z equals 0.866 times 620. So that's 536.935. So this is 536.935. Okay, and then from there, we also have this big triangle. Now we can use our y and z with the Pythagorean theorem to find x. So like y squared, so for instance this squared plus z plus 455 squared is going to equal x squared. So we can just do that in our numbers. Y squared, right, so that's 310 squared plus 455 plus our z squared. So this giant number 108,0036.533. So then x equals the square root of that. So 1039.248. So, because this is 1,039 and she says she can only swim about 1,000 meters, Yiping will have trouble. Okay, and then for this one, 2 plus 3i and b is 1 minus I, so complete the problem. So first you add them, so 2 plus 3i plus 1 minus I. Remember, you just add the real and the imaginary parts. So 2 plus 1 is 3, and then 3i minus I is 2i. A minus b, that's 2 plus 3i minus 1 minus I. So 2 minus 1 is 1, and 3i minus negative I is 4i. And then a times b, right, you want to do like an area model for that. So 2 plus 3i, 1 minus I. So then that's 2 times 1 is 2, and then 1 times 3i is 3i. 2 times negative I is negative 2i. And then 3i times negative I is negative 3i squared, which is negative 3 times negative 1, which is 3. So then you add the like terms. So 2 plus 3 is 5, and then 3i minus 2i is just I. Okay, and then use the properties of logarithms to rewrite each expression so that it contains only one logarithm. So log base 3 of 5 plus log base 3 of m, right, when you add them, it becomes multiplied, so that's log base 3 of 5 times m. Here you subtract its division, so log base 6 of p over m. Here you need to bring this up first, so it'll be z cubed. And then adding becomes multiplication, so it's... but they're not the same base, so that's all you can do. Log base 2 of r plus log base 6 of z cubed. And then here, these are all the same base, so... Or maybe they were meant to have the same base, whatever. So that's log base 90 times 4, which is, or log of 90 times 4, which is log of 360, minus log of 36. And now subtraction becomes division, so that's log of 360 over 36, which is log of 10, which equals 1. Okay, for this one it says... Move my water bottle for the shadow. It says state the degree and sketch a graph. So the degree is 1 plus 2 plus 1, right? How many factors you have. So that is 4, so it's degree 4. And then since the out in front, right, is positive, so then it's going to be like up, up. And then your zeros, right, are the opposites of these, so negative 4, negative 1, and 2. And then at negative 1, it bounces. So negative 4, negative 1, and 2. So it starts like this, goes through here, bounces, and then comes back up. There you go. Okay, and then solve each equation for n. Give both exact and approximate answers, accurate to 2 decimal places. So here, if n is like in the base, you just do that type of root. So n equals the cube root of 49. What you do on your calculator. .659. And then here, if n is an exponent like these ones, and you cannot make the numbers have the same base, like 3 and 49 are not powers of each other, then you need to use logarithms. So you do log 3 to the n is log 49. Then you bring down the n. So n equals log of 49 over log 3, which you do on your calculator. .542. And then this last one, you do log both sides, bring down the exponent, that's n plus 1 times log of 3. So n plus 1 equals log of 49 over log of 3, which we already know from the last problem is 3.542. So this time n equals 2.542 when you subtract 1 from both sides. Okay, thank you for watching.